Hello everyone, my name is Diksha Singh and in this video I will explain the quicksort algorithm. Quicksort is a divide and conquer sorting algorithm that works by selecting a pivot element and divide the other element into two subarray. Those elements less than the pivot and element greater than the pivot. Then it recursively sorting the subarray. So here is the array of this quicksort and here is the algorithm of this quicksort. So the simple explanation of this algorithm is, first, we have to select the element of array A of m as a pivot, and here m is the starting index and n is the ending index of this part of the array which we are solving. And we have to set pointers where I is equals to m and j is equals to n plus 1 means here. Then we have to find values to swap. So in this we have to move I to the right side until we get and we find an element which is greater than or equal to the pivot, and we have to move j until we find the element which is less than or equal to the pivot. And when swap is needed, at that time if I is less than j, at that time we have to swap the position of I and j, and we have to repeat these steps until we get I is greater than or equal to j. Find I is greater than equal to j, at that time we have to swap the pivot A of m with A of j. Then recursive calls means we have to repeat the same process 1 to 6 for left part quicksort m is equals to j minus 1 and right part quicksort which is j plus 1 and n. So here is the example of this quicksort. So here we put our m, here is our n, set I is equals to m and j is equals to n plus 1. So here is our j, and now we have to check the value of I is greater than equal to m or not. So we have to check and we have to move our I from this side. So here we check the 5 is not greater than 26. Now we have to check next value. So 37 is greater than 26. So here we put our I, and from this side we have to check the value of j is less than equal to m or not. So here the first value is less than or m. So when in terms of position I is less than j, at that time we have to swap these two values. So we have to swap these two values. So in place of 37 we put 19, and in place of 19 we have to put 37. So here is our the array. So again we have to check. So here is our m, here is our n, here is our j, and here is our I. And now again we have to check the value of I is greater than equal to m or not. So here we are check. So I is less than 26. Now we have to check next value. So 61 is greater than or equal to 26. So here we put I, and now from this side we have to check the value of j is less than equal to m or not. So yes, 11 is less than 26. So here we put our j. Now again in terms of position I is less than j, then again we have to swap these two values. So in place of 16 we have to put 11, and in place of 11 we have to put 61. And now again we have to start with this loop. So now we have to check. So here are I. So the value of I is less than 26. Now we have to move our I to next value. So 61 is greater than 26. So here is our I, and from this side we have to check the value of j is less than 26 or not. So yes, 11 is less than or equal to 26. So here we put our j, and when the value of I is greater than or equal to j, at that time we have to swap between j and m. So here we swap these two values. So in place of 11 we have to put 26, and in place of 26 we have to put 11. So here is our array. So when we swap between m and j, at that time we divide our loop into two parts. So here we divide our loop into two parts. So here is our first part, and here is our second part. So again we have to check this algorithm in this first part. So here is our m, here is our n, and here is our j, which is n plus 1, and here is our I. So now we have to check the condition that the value of I is greater than equal to m or not. So here 5 is less than 11. So now we have to check another value. So here 19 is greater than 11. So here we put our I, and we have to check j. So here the value of j, which is less than equal to m. So here we put our j. And in terms of position, where I is less than j, at that time we have to swap these two values. So in place of 19 we put 1, and in place of 1 we have to put 19. So here is our array. So now we have to check the condition where I is greater than equal to m or not, and j is less than equal to m or not. So here 5 is less than 11. Now we have to check another value. So here 19 is greater than 11. So here we put I, and for j we check the value of j is less than m or not. So here the value of j is less than m. So here we put I and j, and we have to check the position. In terms of position, the value of I is less than j. At that time we have to swap these two values. So in place of 19 we have to put 1, and in place of 1 we have to put 19. So here is our array. Now again we have to check the condition. The value of I is greater than m or not. So here value is less. Now we have to check next value. So here 19 is greater than 11. So here we put our I. Now we have to check for j. J is less than equal to m. So here 1 is less than equal to 11. So here we put j. And in terms of position, I is greater than j. So when the value of j is greater, at that time we have to swap these two values, means j and m. So in place of 1 we have to write 11, and in place of 11 we have to write 1. So here is our array. So here we solve our first sub part of this array. Now we have to solve this second part. So here is our m, and here is our n. M is equals to I, and j is equals to n plus 1, means here. Now we have to check the condition where I is greater than m. So here the value of 37 is less than 61. So we can't move our I. We put our I here only. Now we check for j. So the value of j is less than m. So here we put our j. Now we have to check in terms of position, the value of I is less than j. So we have to swap these two numbers. So in place of 61 we put 37, and in place of 37 we put 61. Now again we have to check. So here the value of m is less, so we have to put our I here, because the value of I is greater than m. So here we put our I, and for j the value of j is less than equal to m. So here we put our j. So now in terms of position, the value of I is greater than j. So we can't swap, but we swap j and m. So when j and m is at one place, so we can't swap. So here is our final array. Thank you.